Okay, cool. I will be talking today about how we build OCaml at work using Bazel. So first, a little bit about me. My name is Tim Jäger. I work for a company called SandboxAQ. The AQ stands for AI plus quantum. I'm not making that up. I am the DevX team, mostly do Bazel and CI/CD stuff. And outside of that, I also enjoy compilers, cooking, and Cessna. So if you're into that, come talk to me later. Also on certain websites. Cool. So why are we doing this? Why does SandboxAQ do anything? So the Q stands for quantum. So the problem is quantum computers are coming in 10 to 30 years, depending who you ask. And there's an algorithm on quantum computers that you can use to break a bunch of popular crypto systems, such as RSA, as well as Diffie-Hellman key exchange. So if you break those, you also break TLS, which we use to secure all of our communication on the internet. And yes, they're both everywhere. And there's an attack called a store now, decrypt later attack that large players in the information warfare space are already engaging in, where they capture all your traffic now. And then 30 years later, when they have the quantum computer, they'll decrypt your traffic, and then they'll extort you because they know you were posting cringe 30 years ago. And large companies don't want that. So what are they going to do about it? Well, we already know the algorithms that we need to switch to be resistant against quantum computers. Interestingly, we can run them on completely normal computers. They're just not quite as good as RSA and Diffie-Hellman in terms of their performance characteristics. But that's pretty much a solved problem. There's currently NIST standardization going on for these. But what's harder is making sure you migrate all of your vulnerable cryptography to non-vulnerable cryptography. And that's where SandboxAQ comes in. We produce a cryptographic inventory platform. However, software development is hard. So instead of producing this entirely by ourselves, we decided we're going to buy a company. So we bought another company. They're called Cryptosense. They're based in France. So one thing about France is France has a national programming language. It's called OCaml. Here's the programming language tree, which I'm sure you can make out perfectly from the back. OCaml is somewhere down here. It descends from the ML family of languages. Why does France have a national programming language, you may ask? So 70 years ago, France was like hot shit, and they did hot shit stuff, like having like national like institutes for like research. But then they stopped being hot shit, but nobody told the French, so they still act like they are. So they keep developing their own programming language. It's mostly functional. It's basically Haskell without all the weird stuff, in case you've ever seen Haskell. It's used in France. Facebook uses it, and then there's a big finance company in New York called Jane Street that uses it. That are most of the large users, from what I can tell. But so because this company that we acquired is from France, of course, their stuff is written in OCaml. This is what it looks like. Pretty inoffensive, but here's some tweets about. Here's some tweets I found about OCaml. And then so especially for I quite like this one because I'm from Germany, and to me Dutch sounds like drunk German, and I did a lot of Haskell, so OCaml seems like drunk Haskell to me. Anyway, so there's a compilation model to OCaml that we need to know about, like if we want to be able to compile it using Bazel. It's mostly modeled after the C compiler, but instead of one compiler, there's two compilers because OCaml comes with its own bytecode format as well. So there's OCaml C if we want to compile to bytecode, and then there's OCaml opt if we want to compile to native code, which is mostly what we want to do. And then the native compiler, actually, they don't, from what I can tell, they don't implement native compilation themselves. Instead, they emit C files, and then they call the C compiler on that. Here's an output from that, where up here, we see Bazel calling OCaml opt.opt. So actually, I lied to you. There's not two compilers. There's four compilers. For both of those compilers I told you about, you can both compile them either to a native compiler or to a native executable or to a bytecode executable themselves. But anyway, so here we're calling OCaml opt.opt, so the natively compiled native compiler. And then it's calling GCC under the hood. And then down here, GCC is emitting some warnings. And because we're all professionals here, we know what we do with those. We ignore them. But so like that's kind of this is kind of low level and kind of error prone and annoying. So what people in the OCaml community did is they wrote their own build system. It's called Dune. Like it was started at Jane Street. Now it's open source. It's very similar to Bazel in that they promise to be incremental, and your build files, which are called Dune files, they live right next to your source code files, and you can declare multiple targets in them. It's not, however, it's not hermetic, and you can do arbitrary side effects during your build, which of course we can't do in Bazel. And it's pretty much only supporting the building of OCaml applications. So that's kind of bad, but what's kind of cool about it is used by basically everybody in the OCaml ecosystem, so we can leverage this. This is what a Dune file looks like. So they don't use Starlark, they use a Lisp style syntax, which I think is kind of neat, but I find it curious that they don't use OCaml to write their build files. They have a separate syntax for that for some reason. Okay, and then also they allow a bunch of magic to happen in them. So here's a bunch of variables that you can refer to. My favorite ones are the last three, which basically allow you to splice arbitrary files into your build expression in 3 different ways. So yeah, let's talk about the toolchain we built. So first problem we had is bootstrapping, but it turns out it's actually quite easy to bootstrap an OCaml toolchain. The OCaml compiler you can just build with a C compiler and make, and then Dune just needs the OCaml compiler. You don't need any other libraries to build Dune, which is very smart on their part. So after we do those, we can just wrap both of those in a toolchain info and proceed from there like we would usually. And then we had to come up with some rules. So we decided not to reinvent the wheel. So we go with a library binary and a test rule. The signature of those should look pretty familiar to most of you. However, we have some extra arguments. One is the preprocessors, which OCaml developers are used to because the language in its syntax is rather limited. So for certain things like deriving JSON serialization and deserialization, they use basically a mechanism to generate code, which they call preprocessors. We expose that as a separate argument, but under the hood, we just add it to deps because we really don't care about what they do. From Bazel's perspective, those are just additional dependencies. And then by default, the toolchain will use a template to generate a minimal Dune file so that Dune knows how to build whatever we put in the sandbox. And as you already saw, Dune files expose a lot of they expose a lot of knobs. We don't want to reflect most of those knobs in the rule signature. We would rather keep it simple and have a same set of defaults. However, if you really do want to do something special, then you can just provide your own Dune template file and go from there. And we also have a rule that allows us to build external dependencies, so for the most rules, we can provide defaults for build commands and install commands. However, some of them break the mold, and we just leave an escape hatch so that we can override them. And we also have some less typical rules. So because it's a functional language, OCaml developers are used to having a REPL available where they can type code into it and see the result interactively. We just modeled this as a runnable target, and we actually the first 3 rules, so library, binary, and test, we actually made a macro that always includes the actual rule that is referring to, as well as a REPL target, so that for every target, you can also drop yourself into a REPL to interactively play with the code. And then there's also a type check target, which we model as a test that developers can use to get quicker feedback on whether their code compiles or not. All right, this is basically the whole meat of it, where specifically, this is the implementation of the OCaml package rule, where we have to set up a bunch of environment variables so that all of the dependencies can be found by Dune. Kind of annoying that we have to make all of them absolute paths. So lots of calls to pwd, and then we change directory and run the build command and the install command. All right, so we're faced with another problem, which is external dependencies. OCaml, being a rather modern language, makes heavy use of third-party dependencies. We have around 100 direct dependencies, which expand to around 300-something transitive dependencies. So that was kind of tricky to handle. They're basically declared in a .opam file, so we use the regex to get the actual dependencies from there. We wrote a package.json file with those dependencies in it. Now you might say package.json, I thought that's used by JavaScript. You're right, but also it's used by something called ESI, which is an alternative package manager for OCaml. So then we solve those dependencies using ESI, and then we look at the log file that was generated, and what we like about this log file is it's tree-shaped. So then we can serialize that tree and basically pass all of the dependencies, or pass all of the transitive dependencies as the deps argument to any direct dependencies, and then build those. And then we write that out. We merge it with the overrides.yaml file. The reason why will become apparent later. And then we write that out to a deps.bazel file, and then we load that in WORKSPACE.bazel. And we do all that in a Python script because, yeah, we just wanted to add more stuff to it. Okay, here's some issues we encountered along the way. So the OCaml compiler, if you're passing it multiple OCaml source files, it expects those to be in topological order, so that if a module B refers to a module A, you have to pass A before B on the command line. If you pass B before A, like, it'll throw an error, which is, in my opinion, rather silly. So Bazel can't really help you with this because Bazel is not aware of the dependency structure between files, only between targets. And it would be rather laborious to define each target, or to define a target for each file. So in classic OCaml land, they have a separate tool called OCaml dep that first parses all of your files and just basically gives you a snippet you can copy paste into your make file. That'll make sure you call all of these tools in the correct order. But again, we can't do that in Bazel because we can't do dynamic build graphs. Well, guess what? There's another tool that apparently can do dynamic build graphs. So this is from the Bug2 announcement blog post, where they talk about this exact problem and how they don't suffer from it. I don't think there's a compelling reason to switch to Bug2, but I felt particularly called out when I read that blog post a couple of weeks ago. There's, however, a larger problem. So this one's for the Europeans in the crowd. Like, if you don't get this, you probably didn't grow up in Europe. But basically, I told you everybody uses Dune, and that's almost true. But there's one man in Switzerland that refuses to use Dune, and by itself, that wouldn't be a problem. So let's talk about Switzerland first. It's located between Germany and France. So this man in Switzerland, because Switzerland is between Germany and France, the French part of him makes him use OCaml, and the German part of him makes him be very stubborn about using his own build system. So this turned out to be a problem. Here's some more non-relevant facts about Switzerland. The entire country is just 3 banks in the French code. They didn't let women vote until 1990. I'm not making this up. And until 2021, they only had basically their Air Force would only scramble fighter jets to intercept stray aircraft during business hours. They fixed this since, but this is just to give you a picture of the type of place we're dealing with here. So, what's the actual problem? So this guy in Switzerland, he wrote a bunch of very foundational libraries, specifically Unicode handling, which you really don't want to write yourself. So, and he doesn't use Dune, which we rely on to build all of our stuff. So what are we going to do? Well, we were going to despair and basically write a special rule set to handle his libraries. But turns out everybody else in the OCaml community is also very annoyed by this. So they just fork all of his libraries and patch in Dune support. So it turns out what we actually just had to do is we had to go to our overrides.yaml file and swap out the URLs for all of his packages, and then they just built, and that was pretty nice. So here's some lessons that we learned. You should leverage standards that already exist, such as Dune, or basically write rules that conform to all the other rules in terms of their interface. You should always leave yourself an escape hatch. So we allow developers to specify a special Dune file, or we have the overrides.yaml file if there's a Swiss issue. And then lastly, you want to use your screen in portrait orientation so that you can read more errors on your screen while you're working on your toolchain. Yeah,